Hello, and welcome to Part 3 of Hitachi Cable America's Introduction to Fiber Optics. This training presentation is designed to offer a working knowledge of fiber optic product technology to people involved in the design and installation of fiber optic infrastructure. The presentation is comprised of 4 parts: optical fiber components and types, optical fiber standards, fiber cable constructions and applications, and how to field a fiber cable inquiry. This section of the presentation will familiarize you with fiber optic cable designs, terminology, and product uses. To meet the growing number of applications and environments, manufacturers have responded by providing a wide range of fiber optic cable designs. These designs include indoor riser and plenum-rated cables, dual environment indoor-outdoor riser and plenum-rated cables, interlock armored options that are riser and plenum-rated, as well as outside plant cables. All these options ensure that the full range of campus network applications can be supported throughout a variety of on-campus environments. When selecting a cable, ensure the glass is of the highest quality. There are a large number of cable manufacturers in the world. However, the number of companies that draw fiber optic glass strands is quite small. If a cable manufacturer does not want to disclose the manufacturer of the optical fiber, that may be a red flag. If it is a reputable company, they will want you to know, just like an Intel sticker on a laptop informs you of the chip maker. Most cable manufacturers purchase fiber optic glass from a specialized fiber optic glass manufacturer. In these cases, the optical fiber typically arrives from a manufacturer with a 250 micron outside diameter. When the glass is utilized in this manner, the cables are known as loose tube. For additional protection, glass strands can also be covered with a protective layer. These strands are referred to as tight buffered. Tight buffer is a protective sheath extruded directly over the primary acrylate coating of the fiber, providing a high level of mechanical strength, durability, ease of handling, and termination. Typical tight buffer diameter is 900 micron. Tight buffered fibers, like loose tube strands, are color-coded to allow for easy identification. Tight buffered cables are intended to be field terminated. The tight buffer sheath allows for this type of on-site handling, as you might expect in a campus network application. Loose tube, or loose buffer, employs a protective, non-restrictive tube surrounding one or more fibers. This is usually found in cables used for longer distance outdoor installations. Popular loose tube sizes range from 2 mm to 2.8 mm. Microdistribution loose tube cables, a more recent design, are a very flexible, non-restricting, small diameter tube surrounding 12 fiber bundles merged with the strength elements for indoor data center applications. Popular microdistribution subunit sizes are 2 mm and 3 mm. Cable designs up to 144 strands are typical. This graphic provides a good example of how a cable is constructed. Every cable in some fashion is comprised of fibers, cable strength members, and an outer jacket. With tight buffered cables, armored yarns provide longitudinal strength for pulling in the cable. Armored yarns, commonly referred to as Kevlar, though that is the brand name, have for their size a tensile strength greater than steel. With outdoor loose buffer cables, fiberglass rods, in addition to armored yarns, are frequently used as a central strength member, providing both longitudinal strength as well as acting as an anti-buckling device to prevent the loose tube cable from kinking when bent. The outer jacket provides the final layer of mechanical and environmental protection, and it provides specific flame resistance, crush, cut-through resistance, and installation and operation temperature range properties. A special note on cable design. This cable graphic shows a popular protective cable option. A feature commonly seen in electrical cables, aluminum interlock armor spirally applied to a fiber optic cable. This design is extremely durable and yet flexible. This option greatly expands the range of uses and environments for the cable. A significant advantage of this cable design over non-armored ones is the elimination of a protective inner duct. Inner duct is a flexible tube pathway typically installed prior to a cable installation. Inner duct acts as a protective barrier, although it is plastic, and helps identify the cable. Installing armored fiber optic cables negates the need for the inner duct, saving time and money. It is typically available in plenum and riser-rated versions. A plenum-rated indoor-outdoor version is even available from a leading manufacturer. Fiber optic cable jackets are now standardized with distinct color codes primarily directed for in-building identification. This provides easy visual recognition with a cable bundle and at a cable plant equipment room. Legacy multimode fibers, OM1 and OM2, have jackets color-coded orange. High data rate, laser optimized multimode OM3 and OM4 fibers are color-coded aqua. However, there is a movement to attribute Erica Violet to OM4 to distinguish it from OM3. Single-mode OS2 fibers are color-coded yellow. Outside plant and indoor-outdoor cables, being any cable that may be exposed to direct sunlight, typically have a UV-stabilized black outer jacket. Advances in materials, however, have enabled the use of color-coded jackets for some outdoor cables. There are two generalized applications that Hitachi focuses on and supports: campus networks and enterprise data centers. Campus networks follow well-established distribution and contractor channels to market, and Hitachi has a complete tight buffer fiber distribution product offering that covers intended use. Enterprise data centers, requiring very high-density fiber packages for use in restricted spaces, normally follow a cable assembler's channel to market since special connectors are required and cables are supplied in plug-and-play short lengths. This presentation will focus on and thoroughly review tight buffer campus networking cables and just briefly highlighted data center cables. Upcoming product slides will reference several popular connectors frequently terminated to tight buffer and loose tube cables. Here's a brief review. ST connectors, one of the first fiber optic connectors and developed by AT&T, is designed with a spring-loaded bayonet twist on and off mechanism having a ferrule size of 2.5 millimeters. SC connectors, developed by NTT, a Japanese telephone company, is designed with a push-pull latching system having a ferrule size of 2.5 millimeters. LC connectors, developed by Lucent Technologies, is a small form factor connector with a retaining tab similar to a RJ45 connector having a 1.25 millimeter OD ferrule, a very popular connector for high-density rack-mounted systems. Interconnect cables are commonly used with patch panel jumper applications or the last link to an end device and come in 1 fiber, 2 fiber round, and 2 fiber zip cord constructions. Intended for in-building use, interconnect products can either be riser rated or plenum rated. The armored yarns provide for connector strain relief. Common connectors are SC, LC, and ST. Depending on the application, there are a number of ratings and OD size options that can be chosen, including dual-rated riser, rated low smoke zero halogen, LSZH jacket material. Distribution cables with tight buffered fibers are available in both riser and plenum rated designs and is a mainstay product for intra-building backbone applications and campus networks. There are 2 basic product designs, a single unit construction up to 24 fibers and a multi-unit construction up to 144 fibers. The multi-unit cable allows for easier routing of high fiber count cables with the ability to segregate individual subunits to different areas of a patch panel rack. Although cables can be either riser or plenum, most often plenum rated cables are preferred, which can be used both in either plenum or riser applications. Armor distribution cables with tight buffered fibers are available in 2 through 24 fibers in single units and up to 144 fiber in multi-unit constructions. Both types are available in riser and plenum ratings and provide the added option eliminating the requirement to install a cable in a conduit or interduct. Armored cables represent a high-value add-on option for intra-building backbone applications. Armored cables utilize a standard non-armored distribution design and processes these cables with 2 additional steps, armoring and a final outer jacket. The outer jacket aids in installation and identification. Although cables can either be riser or plenum, most often plenum-rated cables are preferred since they can be used in either plenum or riser applications. Indoor-outdoor distribution design is the optimum choice for applications where the National Electrical Code requires outside plant cables to be terminated within 50 feet of entering the building. With cables rated for indoor and outdoor use, the fiber cable can run from outside underground conduit or a lashed aerial location to anywhere within the building. This eliminates the need for an additional transition point, converting an outside plant cable to a NEC-rated indoor cable, and helps reduce costs by eliminating an installation failure point as well as a secure termination location. Armored indoor-outdoor plenum distribution cables up to 24 fibers represent the ultimate and most versatile campus backbone solution, covering the widest range of external mechanical and environmental conditions. Providing a crush-resistant product that is suitable for direct burial or aerial lashed, this cable is approved to directly run through a building's vertical riser and air handling plenum and go directly into an equipment room or telecommunications closet, thus eliminating the service entrance transition point. Loose buffer outside plant cables are still popular in certain types of campus networking applications and reflect a traditional telecom service cable design. Individual tubes may contain up to 12 fibers each, with constructions up to 144 fibers. Loose buffers contain a water-blocking gel and a rugged outer jacketing material, making the cable most suitable for the harshest external environment. Cables are designed for underground conduit or aerial lashing, with options for corrugated steel armor and double jacketing, making the cable crush and rodent resistant for the most severe applications. Depending on the application, there are a number of options that can be chosen, including double jackets and low smoke zero halogen materials. Nanocore is an example of a small diameter micro-distribution cable specially designed to support in-building enterprise data centers. Nanocore cables are typically pre-terminated by cable assemblers utilizing MPO connectors for plug-and-play installations. However, fusion splicing of pigtails and connectors can be done in the field. These products typically comprise high data rate optical fibers in concentrated high-density environments. The next several slides depict common uses of fiber optic cables in a campus network environment. This slide represents a simplified illustration of an Ethernet campus network utilizing OM3 fiber cables in red, OS2 fiber cables in the backbone trunk and fiber distribution runs, then to the workstation and other end devices with copper category 6 or 6A cables in the horizontal. On the right-hand side, you can see the communications network to the outside world coming into the building through what is called a service entrance, which terminates in the main equipment room or main cross-connect. Within the service entrance area is the demarcation point, which transitions communications from the public network to a private network. The service entrance terminates in the equipment room, which houses the electronic communications equipment. The equipment room most likely contains servers, Ethernet switches, and routers supporting other satellite building locations in the campus network. Within the equipment room, either copper cable or fiber optic cables may run between various equipment depending on the complexity and size of the campus network. But if fiber optic cables are located within the equipment room, it is very likely they are indoor plenum rated and may be armored due to the project requirements or for additional safety and security purposes, connecting services switches, or linking up the backbone cable's distribution data throughout the rest of the network. From the equipment room, communications are distributed through the campus network. This is the most common area where fiber optic cables are used due to the bandwidth requirements of a high-speed data network and the distance between satellite locations. In these longer distance backbone applications, outdoor rated cables are generally specified for installation in an underground conduit, and Hitachi provides users with armored and non-armored options. In a 10 gigabit network, OM3 fiber suffices up to distances of 300 meters. For OM4, up to 550 meters. Beyond OM4 distances, OS2 fiber cables are required. With Hitachi's indoor-outdoor rated cables, the user has the ability to run directly to a telecom closet, bypassing the need to transition from an outdoor to an indoor rated cable in the service entrance area. Once in the building, the second most widely used application for fiber optic cables is in the vertical backbone riser. In this application, fiber optic cables provide the interconnection between main data network cable coming from the equipment room to all telecommunication closets. The telecommunication closet contains the connection equipment for workstations in the immediate area, cross-connecting to the equipment room and to the horizontal wiring connections leading to the end devices. The vertical backbone riser, by its very designation, is required to be riser rated. Hitachi has taken this one step further and offers plenum rated cables which surpass the riser flame requirement and has the versatility to be installed in either a riser designated area or an air handling plenum rated area. You should never mix riser and plenum rated cables in a building. Electrical inspectors generally want to see one type of cable present. In campus network applications, Category 6 and 6A dominate the last horizontal link of the network as cables are run from the telecommunications closet to the workstation and other end devices. At the telecommunications closet, fiber cables are connected to an Ethernet switch or an electro-optical transceiver, converting the optical signal back into an electrical signal. In this slide, the end devices may not only include workstations and printers, but also Power over Ethernet, PoE, IP phones, Wi-Fi access points, security access control, and video cameras. Fiber optic cables play a critical role in campus networking applications and specifically support high bandwidth communication systems from the equipment room and backbone connections to satellite locations on through to vertical risers and to the telecommunications closets, and are linked to copper category cables in the last horizontal run to the workstation and other end devices. In summary, there are a variety of fiber optic cables available on the market to meet your specific needs. Remember to only choose products from a well-known manufacturer that is willing to stand behind their products. Thank you for participating in Hitachi Cable America's Introduction to Fiber Optics, Part 3.